Hi, I'm Hongming. This is my first research paper for the course Engineering Self-Adaptive Systems. This paper is called Autonomic Rejuvenation of Cloud Applications as a countermeasure to software anomalies, which was written by these three authors in 2021. The problem the research paper intends to address is related to the software failure of cloud-based applications. Nowadays, it has been changing to deal with the distributed applications. There are several reasons. First, many cloud applications are deployed in multiple cloud regions. Meanwhile, cloud applications often include complex system architectures with high dynamic workloads. This makes it difficult to figure out the root causes of software failure, as well as fix the software anomalies. Next, a complete development cycle to find the causes of software failure, fix them, and publish a corrective version of the applications requires a long time, which leads to long service downtime. Software rejuvenation technology is commonly utilized to solve runtime software failures. The basic action of the technology is to force the application to a clean state where the application can work correctly. The technology is usually used in two ways. One way is when detected to arrive at a failure state. The application is rebooted to force it to return to the correct state. Another way is the application is periodically rejuvenated, which is a sort of preventive action. However, both these two usages are native implementations in the application. This generally leads to increasing computing cost of the application. Additional frequent rejuvenation results in a bad user experience. Therefore, much research was carried out to find out effective methods for identifying and fixing failures. Some studies propose utilizing static code analysis to reduce the possibility of potential software failures. Differently, many proposals focus on how to use specific machine learning prediction models to predict upcoming failures of cloud-based applications. Additionally, some research proposed solutions for detecting failures associated with cybersecurity. Finally, many proposals were about how to improve the workload distributions in related cloud regions, which was good for mitigating the failures of cloud applications caused by overloaded resources in some regions. However, most research simply provides solutions to cope with certain aspects rather than consider the issue as a whole. Additionally, there is little research that offers an extensible framework that allows users to specify which prediction model to use and what failure point to set. The main idea the author had in this paper was to orchestrate the whole lifespan of cloud-based applications to cope with software failure, aiming to improve the performance and availability of the application. The framework the paper proposed was composed of several parts. First, the framework generated different prediction models from the same data collection using a multiple machine learning methods. Then choose the best machine learning model based on their prediction accuracy. Furthermore, users can specify which machine learning models to use. Next, uh, the about to VM state deploying the application was replaced by a new one, which helps to reduce the application's service downtime. Furthermore, users were allowed to custom the rejuvenation method. Additionally, the framework was able to balance the workload among the multiple cloud regions to reduce the impacts of frequent anomalies. Furthermore, the mean time to failure of a virtual machine was treated as an input for the load balancing approach to determine how to redirect requests. Compared to the proposed presented in the related work, the paper proposed a new holistic way to solve the software anomalies in cloud applications. Additionally, the framework that this paper offered focused on the influence of runtime failures instead of on their cause. Furthermore, the paper presented a new kind of load balancing approach that was a highly balanced failure rates in multiple cloud regions. Finally, the architecture allowed users to specify failure prediction models as well as failure conditions. For the evaluation approach of the framework this paper proposed, the authors deployed a web application in a hybrid cloud environment to simulate activities of online retailing. Furthermore, runtime software anomalies were generated by introducing bugs such as unterminate threads and memory leaks. Additionally, the stress test was performed to examine the autonomic management of the framework. Finally, the experimental results suggested that the framework was able to effectively prevent software failures as well as improve the availability of the application. In addition, the probability of highly unbalanced failure in multiple cloud regions had been demonstrated to be reduced. In terms of critique, this paper was well structured. Additionally, the author conducted comprehensive experiments to evaluate their framework. However, the paper did not conduct sufficient discussion of how to store huge monitoring data that is significant for proactively replacing failure VMs. Furthermore, there was no detailed analysis of the limitation of the framework as well as the future research plan. Thank you.